In this video, we are going to discuss on the topic of introduction of signals and how do we generally represent the signals. Okay, so starting with the basic understanding of a signal, let us assume that we are going to communicate with the help of hand signal. Okay, so what is actually happening there is I'm trying to communicate a known information from me to you. So in that case, I'm the transmitter, you're the receiver. I'm going to transmit some useful information from me to you through the hand signal, right? Similar to that, in case of communication also, I'm in need of transmitting some useful information from a transmitter to receiver, and the medium is going to be air or any other optical fiber cables or something, but through which I'm going to transmit the information with the help of the signal. So signal plays a very vital role in case of the communication systems. Okay. So talking about the definition of a signal is a function that conveys information about the behavior or characteristics of a physical phenomenon that varies with one or more independent variables, and the main independent variable in case of a signal is going to be the time period. So based on the time period, I can mathematically represent the signal as a continuous time signal or a discrete time signal. And continuous time signal will denote it as x of t, and discrete time signal we can denote it as x of n. So few examples of the signal is it can be a speed signal, ECG, temperature, image, video, radar echo, everything will come under the signal. But here arises a question, right? Why do I want to study about a signal? Since signal is everywhere when a signal is present, there is always a noise which gets added to it, right? So whenever I'm processing a communication signal, there will be need for me to remove the unwanted noises. And when the file size is huge, there will be a need for me to compress the data, right? As I've said earlier, the signal is majorly used to transmit an useful information, and whenever I'm transmitting, there will be some need for me to store the information, right? And whenever I'm storing an information, there will also be arising a need to detect what is the amount of useful information which is stored in it, and how is actually the physical system works. Whenever I want to analyze the system, I'll be in need of a signal to analyze the performance of a system. Because of all these reasons, we generally study about the signal, and it is used in multiple applications, which includes the biomedical engineering when I'm going with communication or image processing, wireless networking, satellite communication. Everywhere signal plays a vital role. Okay, so coming with the representation of the signal, I can represent the signal either as a continuous time signal or a discrete time signal or digital signal. First, starting with continuous time signal, here we can say that I have an example x of t that is equal to a sine 2 pi ft plus phi, right? This is a continuous time signal. The reason why I am telling that this is a continuous time signal is, if I'm let us assume that the total time period of the signal is between 0 to 2 seconds. Okay, if I'm able to define the characteristics of the signal at any point of time between the time interval 0 to 2 seconds, then I can say such kind of signal as the continuous time signal. Okay, so it will be continuous with respect to time, and I can take infinite number of samples, and the signal will be in the form of an analog signal, and I'll be able to define the characteristics of the signal at any instant of time within the time interval of the signal. Okay, so sine signal can be one of the example of the continuous time signal. Next, talking about the discrete time signal, I'll be able to define the characteristics of the signal only at the given specific time period or time instance. For example, x of n is equal to sine pi n divided by 4. So here the time will be discretized, and the amplitude may still be continuous with respect to the signal. And few example of such kind of discrete time signal is the digital audio samples. And talking about the digital signal, so whenever the time period is actually not continuous, but when the amplitude is continuous, I can call it as discrete time signal. But when the time period is also not continuous and the amplitude is still quantized, such kind of signal is what I call it as the digital signal. Okay, so it is discrete in time, discrete in amplitude, and it is stored in, generally it is stored in computers. And few example is the mp3 audio and digital images. Okay, so far we have actually discussed about what is mean by signal. As I've said earlier, it is a medium which is used to transmit some useful information from one place to another. Generally, we can classify it as continuous time signal and discrete time signal. So, if I'm able to define the characteristics of the signal at any point of time between the given time interval, I can call it as continuous time signal. If the time period is discretized, then I can call it as discrete time signal. If the time period is discrete and amplitude is also discrete, such kind of signal is what we call it as the digital signal. So if we want to define a simple relationship between the analog and digital signal, so when I'm sampling an analog signal, I'll be obtaining the discrete time signal, and when I quantize the discrete time signal, generally I'll get the digital signal. So we'll be discussing in detail about what is meant by sampling and what is meant by quantization in the upcoming sessions. But here, have it in mind, sampling will convert a continuous time signal into discrete time signal. It is simply represented as x of n is equal to x of n into ts, where ts is the sampling period, and we all know that frequency and time period is inversely proportional to each other. And quantization will convert the continuous amplitude into discrete levels. For example, if voltage is 0.72 volt, may become 1 volt depending upon the number of quantization levels which I am going to use and number of quantizers I am going to use. But in case of quantization, I'll not be able to obtain the exact value of the signal exactly at the time period. But have it in mind, when I'm sampling an analog signal, I'll be obtaining the discrete time signal, and when I'm quantizing the discrete time signal, I'll be obtaining the digital signal. So that's all about this video. In the upcoming video, we'll be discussing about the different classifications of the signal. Thank you.